All right, let's never miss another question on von Willebrand's disease. So that's the bleeding, but then the platelets look normal. So we have a teenage girl with gingival bleeding and heavy menses and normal platelet counts, but abnormal ristocetin test that corrects with when you give them plasma. And let's talk about what's happening with von Willebrand's disease so we don't miss this in the future. So you're going to have fatigue and the bleeding and the menstrual. And let's talk about why. So you have chronic blood loss due to heavy menstrual bleeding, and that leads to iron deficiency anemia, and that causes decreased oxygen carrying capacity, which makes you tired and fatigued. The gingival bleeding, von Willebrand, is necessary for platelet adhesion in areas. You have normal platelets, but it's like the glue that holds those bricks together. That's von Willebrand factor. So you have the high shear stress in the small vessels in your gums, and von Willebrand disease causes defective primary hemostasis, which means you have prolonged bleeding from minor trauma. Heavy menstrual bleeding, mucosal surfaces in the uterus are affected by impaired platelet plug formation, and von Willebrand deficiency has poor clot formation on that endometrial surface, and so you have long, heavy periods. Normal platelet count is seen because the platelets are fine. It's the bricks are fine. It's just the glue. The glue is weak. The platelets can't stick together. Abnormal ristocetin cofactor test that corrects with plasma. Well, ristocetin activates GP1B on the platelets and allows them to bind to von Willebrand's factor. So ristocetin test is like, it helps that binding process. And if von Willebrand is deficient, the platelets can't agglutinate, so that test is going to be weird. It's going to be abnormal. So you get the fatigue, the bleeding, the menorrhagia, and the normal platelets and the abnormal ristocetin test. But there are also some trap answers, and so let's dive into this real quick. So 22-year-old woman, nosebleeds, all that stuff, normal platelets, but prolonged bleeding time, abnormal ristocetin and agglutination, which corrects with normal plasma. Boom, we click von Willebrand's, we're good. Von Willebrand's, it stabilizes the factor VIII, and so it can lead to secondary or decreased factor VIII and increased PTT through a bleeding is mainly mucocutaneous. And let's talk about the trap answers here, okay? So these can be tough. So Bernard-Soulier, that's GP1B deficiency, and so it's an inherited defect in those receptors on the platelets. So you can no longer bind with this disease to von Willebrand's factor on those platelets. And so the platelet adhesion is impaired, just like von Willebrand's disease, but for a different reason. So you would also see an abnormal ristocetin test, but it's not going to correct with normal plasma. You also see thrombocytopenia with big old platelets, the big suckers, mucocutaneous bleeding, nosebleeds, gum bleeding, all that stuff. And how do you distinguish it from von Willebrand's? Well, von Willebrand's corrects with plasma. Because why? Because the GP1B thing is there. It works. We just need that glue. We just need that factor. And so change somebody with the glue and it works. Bernard does not correct because, dude, you got a broken receptor. It's not the glue that's the problem. It's the receptor that's broken, right? And so plasma's not going to help you with that. Glanzmann is an interesting defect here. Glanzmann is an inherited defect of the GP2B3A. It cannot cross-link with the fibrinogen. So you have impaired platelet aggregation, not adhesion, just the aggregation. So you'd have a normal test for the ristocetin, abnormal aggregation with the ADP, epinephrine, mucosal bleeding, and you'd have petechia and normal platelet counts. So Glanzmann, how would you think of that? No platelet to platelet clumping. Yeah, that's the platelet aggregation. Glanzmann. Glanz has a party in platelet aggregation. I don't know. Think of something. Factor VII deficiency. That's maybe a good trap answer here. Increased PTT, but you wouldn't see any bleeding symptoms. Because factor VII deficiency, that's a congenital deficiency, like Hodgman's factor, part of the intrinsic coagulation cascade. And so you'd see big PTT, intrinsic, but you wouldn't bleed. In fact, you'd probably thrombose. And so, yeah, you can find this incidentally on the labs. If you think of PTT and you think it's a bleeder, but yeah, this one doesn't bleed. So, yep, I would not pick that answer. So last one is thromboxane A2. That's from aspirin. So aspirin irreversibly, we always need to remember this, irreversibly inhibits cyclooxygenase and decreases the thromboxane A2. And why does that matter? Well, thromboxane A2 is needed for the platelet aggregation. And so you'll have a normal ristocetin test, and you have impaired aggregation with ADP and epinephrine and bleeding risk due to the aspirins. So hopefully this is helpful. Von Willebrand's, bleeding, yes. Bernard, bleeding, yeah. Glanzmann, yeah. Factor VII, no bleeding. Prolonged PTT, yes, but no bleeding. And thromboxane A2 would have maybe mild bleeding, and you have a problem with aggregation. So Glanzmann aggregation and aspirin aggregation. And yeah, that's pretty much it. Hopefully this is helpful, just kind of clarifying some of these different diseases that you might see and knowing how von Willebrand works. So yeah.